In this example, we're going to take the same story of Pottsville and we're going to construct an exponential model for its population growth. So again, in 1980, the estimated population of Pottsville, USA was 33,086 people. By 1981, the population had grown to 34,804 people. Construct an exponential function that expresses the population of Pottsville in years since 1980 and use it to predict the population in the year 1989. So as before, the information hasn't changed. So in 1980, time is 0 since we're counting since 1980 as our starting point, and our population starts off with 33,086 people. And then in 1981, the time is 1. It's been 1 year since 1980, and the population is now 34,804 people. So as points on our graph or on our growth, we have 0, 33,086, and 1, 34,804. For exponential growth, at time 0, we're going to have our initial value. So 33,086 is our initial value. It's our starting point. And for exponential equations or models, we need to have our initial, and then we need to have our rate of growth or decay. Here we're growing, so we're going to have a growth rate, and we need to know what the relative change is as we increase from 3386 to 34,804. And the way we compute our relative change is end minus beginning over beginning. So our total increase was 1,718, and then we divide that by what we started with, and this gives our relative change. So we get 0.051925, etc. And we're just going to round that to 3 decimal places for this problem. So about 0.052, and this is our rate of increase. So when we construct our linear model, we're going to add that to 1. So it's going to be our initial value, 33,086, times 1 plus our rate increase, 1 plus 0.052, and we raise that quantity to the power of t, time, our independent variable. So that would simplify to 33,086 times 1.052 to the power t. And this is our exponential model for the population. So now that we have that, we can go ahead and use it to predict the population in the year 1989. So remembering that we're starting our time from the year 1980, we can say that in the year 1989, it's been 9 years since 1980, hence t equals 9. All right, so we're going to go ahead and plug 9 in everywhere we see t, and we're going to get 33,086 times 1.052 to the power of 9. So L of 9, our population at year 9, is equal to 33,086 times 1.57813. So here we're kind of leaning on our old friend PEMDAS, making sure to do our parentheses followed by our exponents. And then when we finish that, then we can move into multiplication. And since there are no more operators here, we are done. Population is 52,213.87 people, roughly. But since people tend to come in whole numbers, for our final answer, we're going to round this to the nearest whole number. In the year 1989, the population is predicted to be 52,214 people, according to this exponential model.